In this lecture, we'll explore various techniques to circumvent censorship and information controls. We'll start with an overview of virtual private networks, or VPNs, including the capabilities and limitations of VPNs. We'll then dive in to a system called Tor, which is used both for private anonymous communication as well as to circumvent censorship. There are various techniques that Tor relies on to circumvent attempts to block it. The general family of those techniques is sometimes called pluggable transports, and one specific technique that has been developed is called domain fronting, and we'll look at that as a particular circumvention technique. We'll also look at other techniques including steganography and decoy routing. Let's take a look at virtual private networks. We'll explore how virtual private networks work, how people use them, what they're capable of, and their limitations. Now, as we've already learned, not everyone can connect to all web servers or destinations on the internet, and so many people often use proxy servers to circumvent censorship. A proxy server sits outside the censorship firewall, and someone who's behind the censorship firewall may be able to communicate with that proxy server, such as a virtual private network or VPN server, and that server can subsequently reach other parts of the public internet and relay content back to the original user or client through the censorship firewall. This is a widely used technique to circumvent censorship, although governments are getting more adept at both detecting and blocking proxy servers and VPN servers. Over the past several years, we've seen a huge increase in the use of VPN services. It's even been observed that censorship itself can increase access to information because, as a result of censorship, many citizens who are accustomed to accessing that information seek out ways to circumvent censorship. And one of the most common ways of doing so is by using a VPN. The internet is designed as a public network, and the information that traverses it is by default public. Even if the traffic itself is encrypted, the packet headers in an IP packet identify the source and destination of the traffic. Thus, even a passive observer can easily figure out who's talking to who. Even if traffic is encrypted, sophisticated traffic analysis techniques can sometimes even help a passive observer or an adversary determine what content is being retrieved or even what is being said. So encryption doesn't hide endpoint identities. It does hide the so-called payload or the data in the traffic, but traffic analysis techniques also make it the case that encryption itself is not a panacea. The concept of a virtual private network is quite simple. The idea is to encrypt and tunnel users' traffic to a proxy server that's sitting on the uncensored internet. That proxy server can then subsequently fetch information from the public internet and relay that information back to the client over an encrypted connection. This setup, of course, also has some implicit assumptions. One is that access to the VPN server itself is not blocked. Two is that the VPN server or service provider is trusted. And three is that the encrypted connection between you and the VPN service can't be broken or otherwise analyzed to reveal the contents of that communication. It's also worth noting that simply communicating with a VPN server might itself be incriminating. And in fact, in some countries, communication with a VPN server or the use of a VPN service has been declared illegal. The use of VPNs are extensive in enterprise networks. They're often used if the employee is traveling or at home and wants to use the company or enterprise network as if they were physically on that network itself. A VPN can solve that problem by allowing the client who's at home or abroad to tunnel back to a server that's inside the enterprise network, and that server then subsequently relays the traffic within that enterprise network, making it appear as though the client's on the enterprise network itself. You may have used a VPN service if you work for a company or even if you're a student at a university to gain access to the enterprise or campus network if you are physically not located at a company site or on campus. Despite the name, VPNs are not always secure or private. It's worth noting that there are countless commercial VPN providers, many of which are free. And it's often the case that you get what you pay for. Here's an example excerpt of a security audit of a VPN service provider called TunnelBear. That audit revealed a number of critical browser extension vulnerabilities as well as vulnerabilities to the API that could end up revealing both your identity and the content of your internet traffic. Not exactly the characteristic that you'd like to have from a VPN service. Unfortunately, VPNs are not always private either. Facebook notoriously had a VPN service called Onavo that it was marketing as a private VPN service to protect your traffic from observation by internet service providers and other eavesdropping parties. Unfortunately, Facebook itself was eavesdropping the traffic using the service. The service was removed from app stores, and Facebook subsequently renamed the app as Facebook Research so that in an attempt to circumvent that attempt to take the application down. They were, of course, called out for this action, and subsequently the project was shut down. Now, Facebook's Onavo VPN service is a particularly egregious example of a VPN service provider gathering private data and using it. But there are likely many commercial VPN service providers who are performing similar practices. Some of these VPNs have been audited, but there are many commercial VPN services that haven't been. One rule of thumb is that if the VPN service is free, it's probably paying for the operation of its service somehow, and it might be selling your data to pay for the operation of its service. VPNs are also not always functional or even allowed. In the past, both Iran and China have made the use of VPN services illegal. In summary, virtual private networks have several purposes, including providing virtual connectivity to an existing network, such as a campus or an enterprise network, or even the public internet if a client is on the far side of a censorship firewall. People use VPNs for a variety of reasons, including improved privacy and circumvention of censorship or access controls. But VPNs are not a panacea. Many VPNs are not secure or private, and the VPNs themselves can also be blocked or made illegal.